Okay, this is the review for the Chapter 7 mid-chapter quiz. It's in your book. And these are the answers and the explanations for the 20 questions that I recommend you complete before tomorrow's quiz. So first of all, here we go. The first problem, number 1, 5 to the negative 1 times 3 to the negative 2. Whenever we see a negative exponent, we first identify the base, and then we take that base and we move the base and the power to its reciprocal location so that we execute the negative and we now have a positive exponent. So that 5 to the negative 1 is going to go to the denominator. 3 to the negative 2 is going to go to the denominator. That leaves us there. Then 3 squared is 9, and 5 times 9 is 45. So our answer for number 1 is 1 over 45. Okay, number 2. We play the stay and go game on this one, okay? The m has a positive coefficient of 1. It's going to stay there. The n has a negative coefficient of 4. It's going to move down to the denominator. P to the 0 is 1. And q to the negative 2 has to go because it's negative, so it moves up. Now you notice that none of the variables for number 2 were the same, right? So there was no simplifying before I executed negatives. There was nothing to combine or anything. I just got to move what needed to move and leave what needed to stay. And there is my result. mq squared over n to the 4th. All right, number 3. Again, that 3, base 3, it's going to stay in the numerator. X to the negative 4 has to go. It's got to move down to the denominator. And that's our result. 3 over x to the 4th. Number 4. D to the negative 4 needs to go. It's got to go from the numerator down to the denominator so that negative is executed, and it's d to the 4th on the bottom. And t to the 3rd is going to stay right where it's at in the numerator. So number 4 is t cubed over d to the 4th. Number 5. All right, we've got 3 to the 0 times s to the negative 2 times t squared. That 3 to the 0 is 1. So it's going to basically go away because 1 times anything is whatever's left. Then s to the negative 2 is going to go to the denominator. T squared is going to stay right where it's at. So our result is t squared over s squared. Remember, executing these negatives is just moving its base and its power to its reciprocal location. Now we don't have any negatives, but we are multiplying. So 2 times 3, we can just multiply those as we normally would. 2 times 3 is 6. Now x to the 5th times x to the 3/5. I'm multiplying the same base, which means I add those exponents. So 5 plus 3/2 is 5 3/2. Then I can't leave a mixed number as an exponent. So I can change that. 5 times 5 is 25, plus 3 is 28. So it is 6x to the 28 over 5. That's the power. Okay? All right, number 7. A squared is going to stay where it's at. B to the 0 is 1. And then a to the negative 3. We've got to go with that one. We've got to move it. It's got to go. So it's going to go down to the denominator because it's currently in the numerator. So that leaves us with a squared on the top, a cubed on the bottom. If I have 2 a's up top and I have 3 a's on the bottom, once I reduce, I'm going to be left with 1 a on the bottom and then just the number 1 up on the top to hold that numerator open there. All right, number 8. This is 6x and a third times 5x and 2 to the 2/3, excuse me. So again, the 6 times the 5 is as we've always done, gives us 30. When I multiply x to the 3rd times x to the 2/3, then I'm going to add those exponents. 1/3 plus 2/3 is 1, so the exponent on x is 1. We don't write it, it's already there. So 30x is our result for number 8. All right, number 9. B to the 1/2 times b to the 1/2. Simple, straightforward here. We're multiplying like bases. So we're going to add those exponents. 1/2 plus 1/2 is 1. So b has an exponent of 1, but we don't write it there, right? Okay, number 10. I have a to the third times a to the third. Multiplying like bases, add those exponents. A to the sixth. Number 11, we start our section 7.4, or 7.3 rather, which was where we saw power to a power. So that x has a power of 1/4, and that is being taken to the power of 4. So that's like multiplying x to the 1/4 times itself 4 times, right? So instead of adding 1/4 plus 1/4 plus 1/4 plus 1/4, we just multiply it by 4. 1/4 times 4 is 1. So that's the exponent on our x is 1. 3/4 to the 4th power, again we multiply. 3/4 times 4 is 3. So our result for number 11 is x y to the 3rd. Okay, just drop my shoe. All right, number 12. 3t to the 1/6 all taken to the 3rd power. And then 2t to the 0 is taken to the -3. So let's go back. And 3 is a base. It has an exponent of 1. I'm going to multiply 1 times 3. I'm going to get 3 to the 3rd. Well, 3 to the 3rd is 27. That's where we get the 27 there. Then we have t to the 1/6. So 1/6 times 3, power to a power, we multiply, would be 3/6, and we would have to reduce that to 1/2. So that's where we get t to the 1/2. Then t to the 0 is 1. That's why that second t there kind of goes away, because it's just 1. But that 2 has to be taken to the -3 power. So 2 to the -3, I want to make that 2 to the +3, so I move it to the denominator, and then I execute it. 2 times 2 is 4, times 2 is 8. So that's where the denominator of 8 comes from. 13, very straightforward. Power to a power, multiply. 3 times 4 is 12. 14, power to a power, multiply. 3/5 times 5 is 3. So a to the 3rd. 15, we've got 3 bases in those parentheses. So x to the 1st power to the 2nd power there. So 1 times 2 is 2, so there's x squared. Y cubed to the 2nd power is y to the 6th. And z to the 5th to the 2nd power is z to the 10th. Number 16. Now we're getting into 7.4 where we have division involved here. So remember, we don't want to subtract. Okay, we've talked about this in class a lot. It's much easier if we just say, I have 6 b's up top, right? B times B times B times B times B times B. And on the bottom, I've got B times B times B times B, 4 b's. Once I reduce them, I'm left with 2 up top. So 7b squared. For 17, I've got 4 a's up top multiplied by each other. I've got 6 a's multiplied by each other on the bottom. Once I reduce, I'm left with 2 on the bottom. And I put that 1 up in the numerator to show that that a squared is in the denominator. Number 18. Remember, 6 and 3 are numbers like we've always seen them. So 6 divided by 3 is 2. I have 7 x's up top, 4 x's on the bottom. Once I reduce them, I'm left with 3 x's up top. Number 19. Negative 25 divided by 5 is negative 5. A to the 3/4 on top, a to the 1/2 on the bottom. Well, I have to make that 1/2 on the bottom into 2/4 so that I can compare them. Now I have 3/4 on the top, I have 2/4 on the bottom. That means I have 1/4 left on the top. So there's my a to the 1/4. Then I have b times itself 6 times up top, times itself 4 times on the bottom. Once I reduce, I'm left with 2 b's on the top. So there's my b squared. And lastly, number 20, 12 over 1 is 12, so that stays there. 5 halves on top and 2 on the bottom. You'll notice the little circle below there. I showed you my new common denominators, right? So I made 2 on the bottom, s squared, into s to the 4 over 2. So I can say 5 halves on top, 4 halves on the bottom. I'm left with 1 half up top. Similarly for t, I have 7/3 on the top, 6/3 on the bottom. After I would reduce, I'd be left with 1/3 on the top. So 12, s to the 1 half, t to the 1/3. Good luck, guys. Remember, you have more practice on these available to you in the chapter review section. Do 7-1, 7-2, 7-3, and 7-4. Check your answers in the back of the book. See you tomorrow.